Good afternoon, everyone, and welcome to Q&A summer course. So students, welcome to Q&A summer course. I am Sunit Kumar, your mathematics teacher. And students, I'll be teaching the chapter polynomial. So I'll be continuing with that chapter. So we'll do some more questions. We'll practice few more questions. And in the class, what you need to do is try to solve the question and then give me the answer. And if it is correct, that's fine. Otherwise, I'll tell you how to solve that question. Okay. So let's start the class. So as I said, we'll continue with this chapter polynomials. Today is lecture 7 for this chapter. Prerequisite for today's class is you should know about algebraic expression, degree of a polynomial, types of polynomial, value of a polynomial, and zero of a polynomial, right? So in today's class, we are going to do questions based on relationship between zeros and coefficient of a polynomial, and also finding zeros of a quadratic polynomial. So please see this first question. If one zero of the quadratic polynomial is 2, then find the value of k. Attempt the question, try to solve it. Could you solve this question? So here, students, what we need to do, if one of the zero of the quadratic polynomial is 2, so that means if we have a polynomial px is equal to kx square plus 3x plus k, then p of 2, because it is a 0, it will be equal to 0. Put the value of x, replace the value of x by 2. So we will have k times 2 square plus 3 times 2 plus of k is 0. So 4k plus 6 plus k is 0, or we have 5k is equal to 6, or k is minus 6 by 5. So option D is the correct option, k equal to minus 6 by 5 here. Yes, Raghavi, it is correct. So because one of the zero was given, we can put the value of that zero in the polynomial and equate it to 0 and solve it for k. Because k is unknown, we'll solve it for k and find the value of k. Is it clear? Okay. I hope you have noted this down. Shall we move to the next question, students? Okay. So second question is number of polynomials having minus 2 and 5 as 0 is. How many polynomials are possible whose zeros are minus 2 and 5? Yes, Ragul and Raghavi. It is infinitely many because the polynomial px can be written as k times x plus 2 into x minus 5. Because minus 2 is a 0, x plus 2 will be a factor. Plus 5 is 0, so x minus 5 is a factor. So k times x plus 2 into x minus 5. Right? Now the value of k can be anything. It can be 1, 2, and infinitely many values of k is possible. So that's why you can have infinitely many polynomials possible whose zeros are minus 2 and 5. Is it clear to everyone? Okay, let's go to the next one now. So if the product of the zeros of quadratic polynomial is minus 2 by 3, then the value of k, you have to find the value of k. Here the product of zeros of quadratic polynomial is minus 2 by 3. You have to find the value. Yes, yes, correct, Ragul. It is option B. Ragvi, yes. So product of zeros of quadratic polynomial is C by A, which is equal to K over 3, and that is minus 2 by 3. So when you equate it, you will get the value of K as minus 2. When you solve this, you will get the value of K as minus 2. So option B is the correct option. Is it clear? Devi Maya and Tehin, is it clear to you? Okay. Next one, if one of the zero of the quadratic polynomial is reciprocal of the other, then the value of K. One of the zero is reciprocal of the other, you have to find the value of K. Yes, it is correct, Raghavi. One of the zero is reciprocal of the other. So if one zero is alpha, the other zero is 1 by alpha. The product of alpha into 1 by alpha is going to be 1. So product of zeros is 1. So which is equal to C by A. What is C? Minus of K minus 2, and A is 6. Now solve this equation. So this will be 6 is equal to negative of K minus 2, or K minus 2 is negative 6, or K is equal to negative 6 plus 2, that is negative 4, right? So option A is the correct option. Is it clear to everyone? Okay. Next one, please write this down. So if alpha and beta are the zeros of the quadratic polynomial, x square minus ax minus b, we have to find the value of alpha square plus beta square. Use the identities which we have done. Yes, Ragul and Ragvi, it is correct. Okay. So the question says, if alpha and beta are the zeros of the quadratic polynomial, find the value of alpha square plus beta square. Let us find first the sum of zeros. Alpha plus beta is minus of b by a. So negative of a by 1, that is a. And product of zeros alpha beta is c by a minus b by 1, that is minus b. Now alpha square plus beta square will be equal to alpha plus beta whole square minus 2 alpha beta. So alpha plus beta is a square minus of 2 minus of b. So this is a square plus 2b. That is option B. Is it clear? So the polynomial was given x square minus ax minus b. We found the sum of the zeros of the polynomial, that was alpha plus beta. And we also found the product, right? Alpha beta. So alpha plus beta is c minus b by a, and alpha into beta is c by a. We put the values from the given polynomial and got these values of alpha plus beta and alpha beta. Now we expanded the identity alpha square plus beta square in terms of alpha plus beta and alpha beta, right? Once we have done that, we can put the values alpha plus beta as a and alpha beta as minus b. Put the values here and you will get it. Is it clear? Okay. Is it clear to everyone? Tehin, Raghavi, Ragul and Devi Maya, is it clear to everyone? Okay. Let's go to the next question now. So the next question is, if alpha and beta are the zeros of the quadratic polynomial fx is equal to px square minus 2x plus 3p, and alpha plus beta is equal to alpha beta, then find the value of p. So you have to use this relation and solve it to get the value of p. Raghavi, yes, your answer is correct. Ragul, yes, your answer is correct. Good. So here alpha and beta are the zeros of this quadratic polynomial. Now here alpha plus beta will be minus b by a, that is negative of negative 2 by p, that is 2 over p. Alpha beta is equal to c over a, that is 3p by p. P gets cancelled and you get 3. Now what is given in the question is alpha plus beta is equal to alpha beta. Sorry. Alpha plus beta is alpha beta. So that means 2 by p is equal to 3. So p will be equal to 2 by 3, which is your option B. Is it clear? Tehin, Devi, Maya, is it correct? Is it clear to you? Yeah. Okay. Now please do this next question. Question is, if the sum of the zeros of the quadratic polynomial is equal to twice their product, find the value of k. So sum is equal to twice their product. Alpha plus beta is 2 times alpha beta. Using this relation, you have to find the value of k. Yes, Raghavi, correct. It is 1 by 3. Very good. So it is if the sum of the zeros of the quadratic polynomial, so we have this polynomial py is equal to ky square plus of 2y minus 3k. Now the sum of zeros, that is alpha plus beta minus b by a, that is 2 by k. Product of zeros alpha beta is c by a minus 3k over k, which is minus 3. Right. Now sum of the zeros, alpha plus beta, is equal to twice their product, 2 times alpha beta. So alpha plus beta is 2 over k. This is 2 times minus 3. Right. So 2 by k is equal to minus 6, or k is equal to 2 over minus 6 minus 1 over 3.
So alpha plus beta is minus 2 by k.
Yeah. So alpha plus beta is minus b by, yes, yes. We missed the negative sign here. Right. So this is going to give you minus 2 by minus 6, that is plus 1 by 3. Correct. Is it clear to everyone? Tehin and Devi Maya, is it correct? Is it clear to everyone? Yeah. So next question is, if the product of the zeros of the polynomial ax square minus 6x minus 6 is 4, then find the value of a. Also find the sum of the zeros of the polynomial. So product of the zeros is 4 is given. You have to find the value of a and then the sum of the zeros. Yes, value of a is correct. Minus 3 by 2 is the correct answer. Now you have to also find the sum of zeros. So product of the zeros of polynomial alpha into beta is c by a. So this is minus 6 by a is 4, right? So when you solve this, you will get a is minus 6 by 4, which is minus 3 by 2. Yes, sum of the zeros is minus 4. Correct answer. The sum of the zeros alpha plus beta is minus b by a, which is minus of minus 6 over a. So this is 6 over minus 3 by 2. So that is 12 by minus 3, that is minus 4. So alpha plus beta will be minus 4 and the value of a will be minus 3 by 2. Please write this down. Okay. Now the next question is, if alpha and beta are the zeros of the quadratic polynomial 4x square plus 4x plus 1, then form a quadratic polynomial whose zeros are 2 alpha and 2 beta. So you have a quadratic polynomial whose zeros are alpha and beta. You have to form another quadratic polynomial whose zeros are 2 alpha and 2 beta. Are you able to
So
understand this question?
is it, sir, is a quadratic polynomial is 4x square minus 8x plus 5?
No, it is not that. See, if alpha and beta are the zeros of quadratic polynomial, we have alpha plus beta as minus b by a. The polynomial here, you replace minus 4 by 4. This is minus 1. And alpha into beta is c over a. That is 1 by 4. Right? Now we have to find a quadratic polynomial whose zeros are 2 alpha and 2 beta. So sum of zeros will be 2 alpha plus 2 beta. These are the two zeros now. So which is 2 times 2 times alpha plus beta, which is 2 times minus 1, that is minus 2. And product of zeros is 2 alpha into 2 beta. 4 times alpha beta. Alpha beta is 1 by 4. So 4 times 1 by 4 will be equal to 1. So now the polynomial px is of the form k times x square minus sum of zeros into x plus product of zeros. So this is k times x square minus, what is sum of zeros? Minus 2. And what is product of zeros? 1. So this will be x square k times x square plus 2x plus 1. Right? Now if you take the value of k as 1, because there is no denominator in the coefficients, so this will give you the value of the polynomial as x square plus 2x plus 1. Okay. So x square plus 2x plus 1 is the polynomial whose zeros are 2 alpha and 2 beta. Is it clear? Please note this down. So we had a polynomial whose zeros are alpha and beta, and the sum of the zeros and product of the zeros, we can find it from that relation. Alpha plus beta is minus b by a and alpha beta is c by a. Once we have got the value of alpha plus beta and alpha beta, we know that sum of the new zeros, the new zeros are 2 alpha and 2 beta. So sum of the new zeros is 2 alpha plus 2 beta. Take 2 as common, you will get 2 times alpha plus beta. Replace the value of alpha beta as minus 1, you will get sum of the zeros. Similarly, the product of the zeros 2 alpha into 2 beta. 2 into 2 is 4. 4 times alpha beta will be 4 times 1 by 4, that is 1. So now you know the sum of the zeros equal to minus 2 and the product of the zeros is equal to 1. Put it back in the equation. So we know that any polynomial is of the form, you can write it in the form k times x square minus sum of zeros into x plus product of zeros. So the sum of zeros and product of zeros which we have found, we can replace it here and get the value of the polynomial. Is it clear? Okay. Is it clear to everyone? Tehin, Rudra, Raghavi and Devi Maya. Clear to everyone? Okay. Let's go to the next one. So in this question, student, there are three parts. So if alpha and beta are the zeros of quadratic polynomial, px is equal to 5x square plus 5x plus 1. You have to first find the value of alpha square plus beta square, then 1 by alpha plus 1 by beta, and then alpha cube plus beta cube. Do it one by one. Do the first part first. First part, the answer is not 2.5. Can you check your answer, Raghavi? So you have to calculate the value of alpha square plus beta square. Before that, since the polynomial px is given as 5x square plus 5x plus 1, we will have alpha plus beta is minus b by a minus 5 by 5, that is minus 1. Alpha beta is c by a, that is 1 by 5. So first part, alpha square plus beta square is alpha plus beta whole square minus 2 alpha beta. So this is minus 1 whole square minus of 2 times 1 by 5. So 1 minus 2 by 5, which is equal to 3 by 5. Yes, Raghavi, it is correct. So first part is 3 by 5. Second is minus 5. Yes, correct. The second is minus 5. So in the second part, what do you do? 1 by alpha plus 1 by beta. If you take LCM as alpha beta, you will have alpha plus beta here. So which is alpha plus beta, we have already calculated minus 1. Alpha beta is 1 by 5. So this is going to give you minus of 5. So minus 5 is the answer for the second one. Third part, use the identity alpha plus beta whole cube. So alpha cube plus beta cube is alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. Try this one. Alpha cube plus beta cube is alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. Are you able to get the answer for the last part? So this is alpha plus beta whole cube minus 1 whole cube minus 3 times alpha beta, that is 1 by 5. Alpha plus beta again is minus 1. So this will be negative of 1 minus 3 by 5 minus minus plus 3 by 5. Right? So this is 5 minus 5 plus 3 over 5, which is minus 2 by 5. Yes, correct, Raghavi. So answer is negative of 2 by 5. Please note this down. Has everyone understood this?
Understood, sir.
Okay.